All right, class, section 6.3, similar polygons, using similar polygons. So what are similar polygons? It's when you have corresponding angles are congruent and corresponding side lengths are proportional. So if we look at our two polygons here, if I were to say that angle E and angle A were congruent, and G and C were congruent, and H and D were congruent, F and B were congruent, then I could say that I have similar polygons. And instead of a congruent statement, they're not congruent, and you can even tell that EFHG is smaller than ABDC, but the angles are the same. That means that they're similar. Similar shapes, but different sizes, expanded or shrunk. And we're going to show that in our similarity statements. Instead of a congruent symbol, we'll use a similarity symbol. Similarity symbol is just the little squiggle that we normally see on top of the equal sign. That's all it is. So our similarity statement, if I called my first polygon EFHG, I would say it is similar to ABDC. And that would be my similarity statement. Now we talk about the side lengths being proportional. So looking at EF and AB, we can see that they're different lengths, but we're going to make a proportion or ratios that are called scale factors, and that's what our next definition is, that are the same. So we would say like whatever side length EF is over AB, that is going to be equal to the same ratio as EG over AC or GH over CD. They will all have the same proportion or same scale factor. And the scale factor is your ratio of lengths of two corresponding sides. Ratio of length of two corresponding sides. Perimeters of similar polygons. We can use the perimeters of our similar polygons also. And that's the ratio of the perimeter is equal to the ratio of the side lengths or the scale factor. So if we find the perimeter of our first polygon is, say, 20 units, and the perimeter of our second polygon is 30 units, then the ratio of that would be 20 over 30, which could simplify down to 2 over 3, or 2 to 3. It is going to be the same as the ratio of our side lengths of those, which is called our scale factor. So let's put it into practice and see what we come up with here. So in this diagram, we know that triangle ABC is similar to triangle DEF. We need to list all pairs of congruent angles and check that the ratios of corresponding side lengths are equal, and write the ratios of the corresponding side lengths in a statement of proportionality. So let's first look at the angles. We want to match up all of our angles. So if we look at angle A, and we notice our similarity statement, angle A matches up with angle D. So I know that A matches up with D. I can see that B matches up with E. So I know B and E are congruent with one another. C matches up with F. So I know C and F are congruent with one another. So those are all of my pairs of angles. That's just like what we did with congruent triangles. But remember, now the side lengths are different. Now we have to check that the ratios of corresponding side lengths are equal. So let's look at AB. The side length AB is 10. And the side length of DE is 15. Now those are corresponding side lengths, AB and DE. Looking at those triangles, those are the ones that match up. And we can see 10 and 15, they're not the same length. But our ratio becomes 2/3 whenever we simplify it down. We have to simplify it down. Find that simplified fraction. That's what we're looking for. And let's look at side BC, which is 8, over side EF, which is 12. And that simplifies down to 2/3 as well. And then CA and FD. CA is 12. FD is 18. And that simplifies to 2/3. So my ratios of corresponding side lengths are equal. That tells me that my triangles are similar. If any one of those was different, was not 2/3, and if two of them were 2/3 and one of them was 1/3, then my triangles would not be similar. That's our scale factor has to be the same with all of your corresponding sides for the figures, whether triangles or quadrilaterals or pentagons, anything. For them to be similar, all sides have to have the same scale factor or the same ratio, and that's what we call the scale factor. So this has a scale factor of 2/3. Let's actually even write that off to the side so we kind of have that in mind. Scale factor is 2/3. Now the ratios in part B are equal, so we can make a statement of proportionality. And what we're going to do is take the letters of our sides, so the actual names of our sides, like A, B, D, E, C, A, F, D, B, C, E, F, those names, and make our proportionality statement. So we would take AB over DE, they were corresponding sides. And we can see that they are equal to, that ratio is equal to the ratio of BC over EF and equal to the ratio of CA over FD. So even though all of those side lengths are different measures, their ratios simplify to the same thing. So that's what we're looking at. So our statement of proportionality. That was our statement of proportionality. Next, we want to find the scale factor. So let's focus in on scale factor. So we want to determine whether the polygons are similar. If they are, we're going to write the similarity statement and find the scale factor of these figures, DEFG to JKLM. Step 1, we want to identify pairs of congruent angles. So if we identify all of our pairs of congruent angles, we see that G and M we see D and J, we see E and K, So all four of our sets of angles match up with an angle on the other figure. So all of our angles are congruent. And we want to make a scale factor, so we need to show that corresponding side lengths are proportional. So if we look at our side lengths, let's start on the left with DG and JM. So I'll put DG over JM, which is 9 over 12. And that simplifies to 3 over 4. And then if I look at the top, DE and JK. DE over JK is 15 over 20. That simplifies to 3 over 4. Then look at the right side. We have EF and KL. That is 6 over 8. That simplifies to 3 over 4. And then our side on the bottom, GF and ML. Is 12 over 16. And that simplifies to 3 over 4. So we can see that all of our corresponding sides are proportional. All of them have that ratio of 3 to 4. So our our quadrilaterals in this case, these trapezoids, are similar figures. So we can make the similarity statement. And we need to make sure our angles match up, our vertices need to match up, just like our congruence statements did. So if I call my first figure DEFG, it would be similar to JKLM. So make sure your angles match up. And we also need to write out our scale factor. And our scale factor was 3/4. Scale factor of 3 over 4. I guess I got that blank over here. 3 over 4. So in proving figures similar, you need to show all of the angles are congruent and all of the sides are proportional. Now also, notice on all of my sides that I made, I had DG over JM, DE over JK, EF over KL. How did I decide which one went on top, which one went on bottom? Does it have to be the smallest number on top, larger number on bottom? No. I could have started with the other figure and had my larger number on top, and we would have had a scale factor of 4 to 3. That's fine too, but typically, start with the smaller one on top. That's just kind of how you write fractions, right? Smaller numbers on top of a larger number. But I do need to make sure that all of my sides of my smaller figure, if I choose that to go on top, have to be on top. And all of my sides of the other figure need to go on the bottom. So one figure is across the top. All of the sides of the other figure are across the bottom. That is important. All right, using similarity in polygons, we want to find the value of x. So in this diagram, we know these triangles are similar. BCD is similar to RST, and we have to find the value of x. So if we look at the sides that we're given, we know in triangle BCD, we know all of the sides, 5, 12, 13. But in RST, one of the values is x. So we know that 12 over 24 will equal 13 over x and equal 5 over 10, right? All three of their proportions or the ratios are going to equal each other once they simplify it out. So all we really need to do this is two of those. So if I just say 12 over 24 equals 13 over x, so from here I can cross multiply. So if I take these two, 12 and x, and 24 times 13, that'll actually give me 312. Then divide by 12. And I should come out that x equals 26. Now, say you don't have a calculator handy, or you don't do well with larger numbers, whatever it is, you should be able to recognize, because we can simplify 12 over 24, right? So this is the same. 12 over 24 is just 1/2. Equals 13 over x. So I'll show you this still works. 1 times x is just x. 2 times 13 is 26. So if you're able to simplify that, whatever that ratio is, go ahead and simplify it. It's going to make your numbers a little bit smaller to deal with, and you'll still get the same answer. That was finding the value of x. Next, we want to find the perimeter of similar figures. So, in the diagram, we're told that ABCD is similar to FGHJ. We need to find the scale factor of FGHJ to ABCD. So notice they told us which number they want first, or which number they want on top. They want the FGHJ on top. So we are dealing with a smaller one on top. And then find the perimeter of FGHJ. So let's find the scale factors. So we know the only side length we know on FGHJ is 8 on JF. If we look at our similarity statement, J and F match up with D and A. So side length AD or DA is our corresponding side. So we have JF over DA equals 8 over 12, which then simplifies to 2 over 3. So that would be our scale factor. Scale factor of FGHJ to ABCD. We also need to find the perimeter. So if we're going to find the perimeter at FGHJ, we need to be able to add up all of its side lengths. We only know one of the side lengths. So how do we find the other side length? we're going to use our scale factor, and we're going to use the perimeter of our other figure. So our other figure's perimeter, we have, so we're talking about A, B, C, D's perimeter is 15 plus 8 plus 10 plus 12, which is 45. So we've got a perimeter of 45 for our ABCD. The perimeter, so I'll write this out, perimeter here is 45. Perimeter here is just X. We don't know what it is yet, right? That's what we're trying to figure out. So that perimeter is X. So we're going to use our scale factor of 2/3. And we know our scale factor is going to be equal to the ratio of our perimeters. So it is going to be equal to X over 45. And then I can cross multiply. 2 times 45 is 90. And 3 times x is 3x. Divide 90 by 3. X equals 30. That's our perimeter. And that's all we needed to do. So we were able to find the ratios of the perimeters, or find the perimeter using the ratio of it and the scale factor, knowing that those two are equal. That is it on the notes. Make sure you do the 6.3 homework.